So here we are. We've been through, what happens at the neuron as it comes down here. This is that area here. You've got the acetylcholine in the vesicles. You've got your calcium coming in through those voltage-gated channels. Acetylcholine from exocytosis is coming across the cleft. It's binding to the chemical channels, and now we have the end plate potential here. That is causing the action potential with sodium channels here, and that is going to go into the T-tubules, which is where we ended up in the last one. So the action potential is coming down into the T-tubules, and what it's going to encounter, remember these T-tubules are wrapped around the myofibril, and on either side of them are those parts of the sarcoplasmic reticulum called the terminal cisternae. So there's going to be little proteins, and they're not really channels, but they look kind of like channels here, but they are proteins that are going to be affected by the action potential coming down, and it's going to change the shape of those proteins and open them up. And when they open, these calcium ions you see here are going to flood the intracellular fluid. They're going to come out of this sarcoplasmic reticulum. When they do that, they're basically flooding out and going all over the sarcomeres. Okay, so down here, it doesn't show that. Remember, this is a myofibril, so there's going to be actin and myosin in here that are covered with that are under the sarcoplasmic reticulum, and the actin. So here's the thin filament, or the actin. So keep in mind that the actin binding sites for myosin are blocked. They're blocked by this tropomyosin here. So the calcium is going to come and it's going to bind to troponin. And troponin is going to move that tropomyosin out of the way, and it's going to expose those actin binding sites. When that happens, then myosin is going to come up and bind, and it's going to provide its power stroke. So it's going to pull the actin towards the M line. Pull actin toward the M line. And that shortens the sarcomere, which shortens the muscle. Okay? So when that happens, and there's, myosin heads all up on here, right, that are next to the actin filament here. And these these myosin heads have already been energized because they've already been phosphorylated by ATP. So they are bound with ADP and inorganic phosphate in their ready position. So they're laying here ready to go with ADP and inorganic phosphate attached to them. And as soon as they go up and bind and do their power stroke, that inorganic phosphate and the ADP goes away. It's used. It uses that energy. And once it's gone, it's kind of stuck here on the actin. It's literally stuck there. It can't let go. So an ATP molecule, so ATP has to come in here and bind in order for that head to release. Once it releases, then it will phosphorylate as it's going back down into its ready position. And it'll phosphorylate, and it will end up giving it an ADP, an inorganic phosphate, so that when it's back in its ready position, it's already energized and ready to go to bind again. And it will keep doing that. That's called cross-bridging. I should put that over here. But that's called cross-bridging, and it will continue to do that until the calcium So the calcium here gets actively transported back into the sarcoplasmic reticulum. This right here is a calcium pump. It's actively active transport, so it is being fueled with ATP as well. Okay, so once that calcium goes back into the sarcoplasmic reticulum, then the tropomyosin goes back into its place and the binding sites on actin are blocked again. And then relaxation occurs. So then we have relaxation and the muscle contraction is over. So that continues to occur until all that calcium, or until the calcium goes back into the sarcoplasmic reticulum. Okay, so that is everything that happens that creates a muscle contraction. Okay, so remember, coupling. I'm having a brain problem. Anyway, so remember that the action potential is coming down the neuron. It's going over to the motor end plate, goes into the T-tubules, opens the doors on the T-tubules, and lets out the calcium. Once the calcium binds to troponin, we now have a mechanical thing going on. The action potential is over. So we're linking together an electrical event, an electrical stimulus, to a mechanical event. Okay, and that's called EC coupling, or excitation, contraction, coupling. Okay, I think that basically explains that. You want to go through that many times. It takes a bit. But if you understand those steps and what's happening here, it will really make the neuro part, when we get into chapter 12, a lot easier to understand. So make sure you go through that over and over.